My talk about must-have skills to become a data scientist. So there are many vacant lines in my slides. So I'd like you to take note while listening to my talk, okay? Are you ready to take notes? Okay? So the first is the definition of big data. So big data, it's a data set that are so voluminous and complex that traditional data processing application software are inadequate to deal with them. So take note of this one. Okay? I think this sentence are vacant, so take note. The source of definition of this definition is comes from this URL site, okay? Wikipedia. Okay, let me move on to big data statistics and facts for 2017. This was posted on February 22nd. Last year. This is the source. So big data in today's business and technology environment. Key part are vacant. So 2.7 zettabytes of data exists in the digital universe today. Today means last year. At the time, February last year. And 235 terabytes of data has been collected by the US Library of Congress in April 2011. This part is missing, so please add this part. On the internet, we reach 450 billion. In the slide, only will reach. So this red part is missing, okay? Do you know how much is zettabytes? Do you know? Zettabytes.
It's a large amount of
Yeah.
bytes, but I don't know precisely how big is it.
Yeah. Okay, so it's so big. So mega, giga, tera. You know, I think you know this. Then peta, exa, zetta, yotta. Next, another statistics and facts. So these are unstructured data. YouTube users upload 48 hours of new video every minute of the day. Mm. 571 new websites are erected every minute. And 500 terabytes of data uploaded daily to Facebook. Okay, next. Next is the statistics and facts about the market and the marketer's challenge with big data. So most of this part are already filled. I'd like you to take note of this one. Shortage of 540,000 to 190,000. Too few people with deep analytical skills to fill the demand of big data jobs in the US. You will be the persons with deep analytical skills. You are going to fill the demand. Shortage of this amount of persons. Okay. I think you will have many chances in the near future in this field. This graph shows the trend of big data. The horizontal axis is year, and the vertical axis is exabyte. So take note of these words. So the big data increases exponentially. And this portion is occupied, this one, corporate data. This is occupied by IP communication, social media, and sensor data. Okay? Take note of these words. Now, this slide shows an image of cloud computing. Tablets, phones, laptops, servers, database, desktop. These are connected by internet. And computing is done in cloud. So this is just an image, cloud computing here. Material is over there. This is another image of cloud computing. It's in hierarchical structure. So infrastructure, platform, and application. Okay. So infrastructure consists of computer, storage, and network. And the platform consists of these, the platforms for query or database or computation or storage. And on the top of this platform, there are many applications, application software. Let me skip this slide. Later, I'll come back to this slide. So this is another image of cloud computing. So recently, this part is emphasized. The importance of this part is emphasized. Between sensors and controllers and cloud, there should be edge computing. This is one of the important keywords, edge computing. So these are unstructured data, and if you put this data into cloud, then in the cloud computing, the load of computing becomes very large, or even the cloud computing cannot handle the unstructured data. So before transmitting or sending the data to cloud, directly to cloud, data cleansing or filtering or some preliminary computing is necessary at this stage. So these are the contents of cloud computing and edge computing. Okay, so in the cloud, this computing will be carried out. Complex analytics, big data mining, sources of business logic, machine learning, visualization, some like this. And in order to make the computing efficient, we need this edge computing, especially data pre-processing, cleansing, filtering, and optimization. So this slide shows the purpose of data science, the role of data science, and computing, the purpose of computing of big data. So you'll be data scientist, and you'll work. Probably you'll work here for automated data-driven decision making. Or beyond that, across the firms, this type of data-driven decision making will be necessary. Later, I'll talk more about this. So again, this is the trend of big data. Here, I'd like you to take note this one, IoT, sensor data. This is also another keywords of the big data analysis, IoT. So what is IoT? It is Internet of Things. So the IoT is a network of physical devices, vehicles, home appliances, and other items which enable these objects to connect and exchange data. 2 weeks ago, I visited an exhibition held in Tokyo. It was an wireless IoT exhibition, very big exhibition. So the 50,000 people attended the exhibition for 3 days. So there are main electronic companies or information companies like NTT, NEC, Toshiba, Panasonic, and they exhibited the IoT devices, IoT equipment. There are many small companies, venture companies, so they are developing IoT devices or equipment. So please go back to this slide. I skipped this one. This explains exactly the IoT. So please take note of these words, things and networks. Things are connected through gateway to networks. And analytics are done. I think you already know about IoT. Let me explain. One example, a successful example of IoT. It's called Comtrax. Comtrax is a wireless machine tracking system developed by Komatsu Limited. Komatsu is one of the major manufacturers of construction machines, shovel cars, bulldozers, like that. And these are strategic machines. So this should not be exported to certain countries who are hostile to us. So the Komatsu have to track all the machines they sold. So these machines are bought by many nations, many companies in nations in the world. So the this machine has this GPS system. So through this cellular phone network, the Komatsu can know where it is. Even it is in Brazil or USA or Europe, the Komatsu can know where it is. Also, the Komatsu can provide service to users. So this Comtrax can provide a number of key features. These features: machine location, work monitoring, security, and also machine performance. This is an example of tables. This shows the operation monitoring. On February, what kind of maintenance was done? Also, this slide shows the machine location of one machine. It was moved from here to here on December 15th. This is one example to track the location of machines. Komatsu, also the user can know where the machine is. Also, the Komatsu can provide these information to users, working hours or accumulated working hours. So those data can be used to detect abnormality. Well, this is an example of the detect of abnormality in the exhaust temperature of rear engine. So blue line shows the exhaust temperature of front engine, and green line shows this one, exhaust temperature of rear engine. Suddenly, that temperature rose up at this stage. So this helps to prevent serious damage of engines. So this graph shows the blow-by pressure. So it is to detect the gradual increase of blow-by pressure. And the life of engine was predicted. And an optimal plan of engine overhaul was proposed to the user or to the customer. So this is the limit of this blow-by pressure. So this is to reduce maintenance cost, and it is to keep high operating ratio. In the near future, this kind of connected vehicle will be realized. So this word, connected vehicle. So this car is connected to the internet or connected to another car. So these kind of services, intermodal services, car sharing or e-call, or insurance, use-based insurance, or automated driving or something like that will be realized. So as I told you, I attended the exhibition. At that exhibition, one of the Toyota executives gave a talk to us. There are so many engineers or professors listening to his talk, and he talked about this one, connected vehicle. And he said that we need engineers, scientists. So if you will be an employee in the future of Toyota Motor Corporation, you will work for this field, not for designing cars. They don't need so many engine designers, car designers. They need designers of this system. You'll have chances. Another one is a smart house. This is another IoT. I think I don't need to explain this. I think you can understand what they are. I don't know whether this is really convenient for you. I don't know. So the Internet of Things, from factory to home, all are connected through Internet. So this slide shows the prediction of the market, IoT market. It will also grow exponentially. I think you are learning skills necessary for data scientists. They are business problem solving, data science, and data engineering. I think you are learning some of them. In order to be a data scientist, you don't have to master all of these, or it's almost impossible for anyone to master all of these. So this triangle shows the paths, 3 career paths to data scientist. Some of you belong to this IT engineer, and some of you belong to this scientist, just a scientist, or data engineering. A few, I think few are in this field market here. So the business problem solving. This skill belongs to marketer, and the data engineering belongs to IT engineer, and data science belongs to scientist. Do you know these keywords? I think you know some. Statistical hypothesis testing, Bayesian statistics, network analysis, or neural network, regression analysis, reinforcement learning, machine learning. Or these are related to IT engineers. Hadoop is a framework for big data processing. Pig is a platform run on Hadoop. This is very convenient for programming, more convenient than Java. Hive is another platform for database system run on Hadoop. Nine must-have skills you need to become a data scientist. Including this non-technical skills, intellectual curiosity. So please take note of these words: education, SAS and or R, Python, Hadoop, SQL, unstructured data. So you are satisfying this one. 88% have at least a master's degree, and 46% have PhDs. Their most common fields of study are mathematics and statistics, computer science, and engineering. How many of you use SAS, SAS? Raise your hand. No one. R. How many of you use R? No one? You? Only you? How about Python? Oh, yeah. Hadoop? No? Oh. Okay, mathematics. Calculus, linear algebra, and functional analysis. These are very important. So let me go back to the triangle. Here, Mahut. I don't know how to pronounce this one, Mahut. This is a platform of linear algebra. So linear algebra is very important for big data analysis. Do you know how to differentiate matrix? Do you know? Does anyone know how to differentiate matrix? Only you? Oh. You will use that one in the analysis of machine learning. Okay, statistics. I want to know how many know this. So I think you know central limit theorem, standard normal distribution. How about this one, chi-square distribution? How many know? How many of you? Only 3? Oh. Student t-test. Only you? Or you? Which is t-test? Only you? Multiple comparison. Oh. I believe that you should run this multiple comparison. In order to be a data scientist, you should know this. Next is the multivariate analysis, regression analysis, factor analysis, ICA, independent component analysis, PCA, DA, SVM. Okay, again, I'd like to ask, how many know this one? Regression analysis, how many of you know this one? Factor analysis. ICA, independent component analysis. SVM. This is very famous. Yeah. Okay, take note of these words: supervised learning algorithm, unsupervised learning algorithm, and ensemble learning techniques. So this slide shows top 10 machine learning algorithms for beginners. Okay. So this is another supporting evidence that there are few data scientists in the industry. Even you, many of you do not know these algorithms, these analytical methods or statistics. So if you run this, then you'll have many chances to be a leading data scientist in the industry in the future or in the academia, okay? Now, the rest of the slides shows details of top 10 machine learning algorithms, unsupervised learning, reinforcement learning, and machine learning methods. There are many, many methods, many. So you don't have to be overwhelmed of these many methods, but just start from these. You can start from these. Okay, do you have any questions, comments? Homework. Summarize today's talk using all of the following words. Okay, big data, cloud computing, edge computing, IoT, data scientist, skills, mathematics, statistics, multivariate analysis.